Hi, this is Ranger Jonah with DeKalb County, and I'm out in the woods, though I guess you can see a house behind me too. I'm out in the woods between a couple neighborhoods, and today I'm gonna do something with you that I have not done very much. It's something I'm learning, and I'm gonna invite you to learn along with me. It is stream water monitoring. What monitoring means is checking up on it. And stream water, of course, is the water in our streams, like this one here. I'm walking next to a nice little stream near my house, and I want to check on the water quality to see how well the water is doing after a big rainstorm that we had last night. I want to see how well the water is doing for animals and plant life in the stream. I'm not going to be doing chemical testing, so I won't be able to tell you directly what any pollution is, but we will be able to check on oxygen levels and pH levels as well as water temperature. So I'm going to get myself set up, and then we'll do a little bit of stream water monitoring together. Okay, I've got all my stuff out here. I'm going to bring the camera a little bit closer, and then I'll show you how we test and monitor this stream water. Okay, I'm right here next to the stream, and I've got my handy monitoring kit here. We are going to do 3 different tests of this stream, and the first thing we'll do is not from one of these boxes, but rather from this device right here. This is a thermometer. It's inside a purple plastic case with a lanyard so that it won't get lost or broken in the stream. But what I'm going to do first is I'm going to attach this thermometer to one of these trees and get it soaking in the water so we can see how warm or cold the water is. If the water is too warm, then that could be a sign of a problem. And if the water is too cold, it could also be the sign of a problem too, but likely if we find something, it'll be that the water is too warm. So let's put this in the water. I've got a nice spot right here. And a little pollution here. I'll throw that away. And I just dip this down in the water, and I'm going to hook it to a stick so it won't float away. And we'll let that stay there in the water for our first experiment, and then we will check it. So first of all, I'm going to get out my first testing kit. This one is a pH measurement kit. Again, I'm just learning about stream water monitoring, so I need to learn some chemistry. What does pH stand for? I think I'll have to Google it. But what pH does is it's a measurement scale to see how acidic or how basic any kind of material is. So for instance, if something is very acidic, you might think of a lemon or vinegar. If something is very basic, you might think of baking soda or ammonia. So what we want to make sure of is that our water is not too acidic. You can imagine animals would not like living in lemon juice, and they also would not like living in baking soda. So we want the water to come out right in the middle of the pH scale, as close to neutral as we can get. So probably between 6.5 and 7.5 is what we hope this water will test at. The neutral on the pH scale is 7. So we open this up, and you'll see we have a pH scale right in front of us. If you can read those numbers, you'll see that this one has 7 right at the top. I also have a second pH scale just in case we find that our water is more acidic. This one is if the water is more basic. And with this kit, the first thing I do is I have to fill up a test tube full of stream water. So here I go. Let's see if I can do it without getting my feet too wet. All right. So what I have here is nice clear stream water. I have 10 milliliters of clear stream water. And what I'm going to do is I'm going to take this solution right here, and this is an indicator, a pH indicator, which, depending on how acidic or basic the water is, will turn it a different color. How many am I supposed to put in? It's usually 8, but this one might be 10. Let's see. 10 drops. One, 2, 3, 4, 5, 6, 7, 8, 9, 10. Cap it, and then mix it. Do you see how that water has turned colors? That's not necessarily because the water is polluted. That is the pH indicator. And one of the great things about this is this did not turn a very deep green or a very deep orange color. It looks like it's kind of a greenish yellow to me. So what we do is we have our pH meter, our pH scale. We put this right in here, and then we figure out what color on the scale is closest to the color of the water. Well, when I look at this, the closest is the very top, 7.0, but that's a little too green. So I think our water is slightly acidic. So I take out my other pH scale here, the one that has 6.5 down to 3, slide it in, and would you agree with me that our water is closer to 6.5 on the pH scale? Yeah. So our water is slightly acidic here, and it is within the range of safety though. So 6.5 is very close to neutral, and that is a good thing. pH, we've just confirmed that our water is not too acidic and not too basic. Now that we've done pH, our thermometer, which we put into the creek, has now had a little bit of time to cool off in the stream water, and we can pull it out and check the temperature. I don't think you'll be able to read it on this camera, but maybe you can. It reads 21 degrees. Wait, 21 degrees you say? That's below freezing. Aha, but this thermometer measures in Celsius. When you do stream water monitoring, we always measure using the metric system. And so this particular one, 21 degrees, measures out to roughly 67 degrees Fahrenheit. Now, that's a little cooler than I would typically expect. What I've seen with other stream monitoring is that usually it's in the low 70s, but 67 degrees Fahrenheit is pretty close to 70, 71 degrees Fahrenheit. The other two things I know about this creek, which leads it to be probably a little bit chillier than other creeks, is that one, it's very, very close to its headwaters. This creek starts almost at the Continental Divide, and we are very, very close to where this creek starts. Two, because there was a big rainstorm yesterday, rain has just entered the creek and likely hasn't had as much time to be warmed up by the sun. So that's another reason why our temperature is at 67 degrees Fahrenheit, or perhaps 21 degrees Celsius if you're a metric system person. You ready for the last test that we're going to do on this water? Let's go. Our next monitoring test is for dissolved oxygen. Oxygen is always in the air. It's what we breathe. But do you know what else needs oxygen to survive? Well, animals that live in the water. Just like we have lungs that take oxygen out of the air and put it into our body so our bodies can use it, fish and other animals with gills also take oxygen out of the water and then use it in their bodies. So a stream has to have oxygen in it. How does oxygen get into water? Well, oxygen is always going into water and out of water, particularly at a place where there's a waterfall or a rapids. Water is churning and churning and churning, and lots more oxygen gets into the water. What we want to see is we want to see that this creek has enough oxygen to allow plant and animal life to survive. That means at least 5 parts per million of dissolved oxygen, and that's what we're going to test here. I'm excited to do this one with you and also a little nervous. This is only the 3rd time I've done this test. I was taught by our watershed department here in DeKalb County. One of our educators named Michael O'Shield taught me how to do this and gave me this kit, and now I'm using it to try to explain it a little bit more to you. So if I get something wrong or maybe do the experiment just a little wrong, be patient with me. I'm learning, and hopefully this will help you learn too. So we've got our kit. And there are so many more reagents, which is another term for chemical, inside this kit. But the first thing we have to do is collect some water. So I'm gonna do that. All right, so now I've got a full bottle of water and I do not see any bubbles inside. So now the next things that I need to do is I need to put 2 solutions inside. The first, let's see, I need to make sure I'm doing this right though. The first one I'm gonna put in is manganese sulfate solution, and then I'm gonna put in alkaline potassium iodide. Yes, you have to be a chemist to know all about these. But what this is gonna do is it's gonna trap the oxygen into the water. So then I can take the lid off and the oxygen won't escape. So I'm gonna double check that I'm putting the right amount in because, again, we always want to do the experiment right. Manganese sulfate and alkaline potassium iodide. So I need 8 drops of each. And I don't wanna keep the top off on my water sample for very long because oxygen starts going into it. All right, here we go. 1, 2, 3, 4, 5, 6, 7, 8. Sounds like a drum machine has started up in the house nearby. 1, 2, 3, 4, 5, 6, 7, 8. And now I cap it again. Do you see the difference? Look what happened. It turned a different color, a very different color there. All right, I'll cap these 2 now. I'll put them away. And then the next step is, I believe, to wait until that settles just a bit. Again, I'll double check. I want the orange color to settle just below the label right there. And then I'm gonna add the one and most dangerous chemical here, sulfuric acid. I'm back and the precipitate has settled down towards the bottom. That means it's time for me to put the 8 drops of sulfuric acid into the solution. This will trap the oxygen. It'll be the end of the process and will trap any oxygen that was in the water when I first collected it. 1, 2, 3, 4, 5, 6, 7, 8. Cap it. And do you see how it's changing again? Now, invert the bottle, mix it up a little bit, and the solution has this nice orangish color with little particles floating around in it. The next step is to take this titration test tube. Yes, titration test tube. And I need to fill it up with 20 milliliters of this solution that now has trapped oxygen in it. 20 milliliters. Put the cap back on. And the next step is to titrate. I'll put the titration lid on. The titration lid has a tiny little hole in the top that I can put my titration syringe into. But first, I have to get some sodium thiosulfate. You've probably seen a nurse do this at the doctor. But this is not the kind of needle you stick into a human. A titration syringe just allows you to put just a tiny, tiny bit in. I'll tilt the camera a little bit so you can see the color of the solution, because it will change as I drop some in. And then I'm just going to swish it around, and we want the color to get to be a very light yellow. Oh, there's a very light yellow now. See how much the color has changed? So the next step is for me to put in 8 drops of this indicator solution. And this will allow us to know exactly when all the oxygen has been titrated out. 1, 2, 3, 4, 5, 6, 7, 8. Do you notice the color change? It's turning kind of a purplish blue. That's the indicator solution. I'll shake it up, and now we got this beautiful purple color right here. Now I should be able to use the titration to get this water to be completely clear. Still kind of blue, so I'll put a few more drops in. Almost completely clear, just maybe a little bit more of a drop. And I still see a little blue. I'm gonna pick 2 more drops. Have you ever seen somebody do a chemistry experiment outdoors? Now you have. And look at that clear, clear water. So how do you test it? How do you measure it? How much oxygen is in it? It's how much titration fluid that I had to use in order to titrate all of the oxygen out of the water. I look at my mark on the side, and it looks like that, y'all, this water is just slightly under oxygenated. It only took me 4.5, which means that this water does not have quite enough oxygen in it. So what have we found out today? Well, first of all, we measured the pH and found that the pH of the water has the water being slightly acidic, but very close to neutral. That's good. The next thing we found out was that the temperature of the water might be slightly colder than a stream would typically be, but we had some pretty good reasons why that might be okay. The third thing we found is that the water has slightly less oxygen than we would typically be happy with in water this way. So what is my verdict from this stream water monitoring that I've done? That the stream is mostly healthy, but it's kind of on the edge. And the important thing to do is that I come back to this stream month after month and retest it, doing the test exactly the same way each time, which is the way good science is done, and then recording my results month after month after month after month. And then we can see trends of how the temperature, oxygen levels, and pH of this water changes over time. Would you like to do stream water monitoring? Well, the best way to learn is to go to Georgia Adopt a Stream, and you can find all the different places where groups, including schools, have adopted sections of our waterways and do regular testing. You can even go into the results and see how the water close to your house has recently been tested. I hope you've enjoyed doing some science experiments with me. And before I go, I got to make sure and do one thing. I got to take all of the water that I've put chemicals in, and I've got to put it in my refuse jar because I don't want any of those chemicals going into this stream. I think I'll pick up some of the trash that I found in the stream too. I hope you have a great day. This is Ranger Jonah doing stream water monitoring and now signing off. all taken care of, and none of the chemicals will go back in the stream.